Hello, my name is Jiahao Li. I am a PhD student under the supervision of Professor Jianping Wang at the City University of Hong Kong. In this video, we will introduce our latest work for stereo matching, which is accepted by the ICCV 2025, called Global Regulation and Excitation via Attention Tuning for Stereo Matching. In this paper, we are aiming to solve the ill-posed issues in stereo matching. The core technique in stereo matching is to find matching points between the left and right image. However, sometimes it's hard to find this matching point, like in the occlusion, textureless, and repetitive patterns region. Through our observations, we found that all these ill-posed regions are caused by ambiguous contextual information and the coarse geometric structure during the matching. So the key solution is to introduce finer and richer global contextual geometric information. Based on that, we propose the GREAT framework. Our main contributions can be separated into two main parts. The first one is the universality. We introduce a framework named GREAT, consists of three well-designed attention modules: spatial attention, matching attention, and volume attention, which can be seamlessly integrated into existing iterative stereo matching methods. The second contribution is the ill-posed tackling capability. With our framework, the existing iterative stereo matching method can aggregate richer global contextual information through the spatial attention and matching attention. And volume attention will take the output from the spatial and matching attention to excite the global geometric information into the 4D coarse volume to optimize the ill-posed issues. To evaluate our GREAT framework, we conduct extensive experiments. The first one is the universality verification. We take three well-designed iterative methods called raft stereo, IGV stereo, and selective IGV to be the baseline, and integrated with our GREAT framework. Through the experimental result, our GREAT framework can be seamlessly integrated into existing iterative-based stereo matching methods and obtain a large margin optimization. The second experiment is the cross-dataset verification. We evaluate our GREAT IGV and GREAT selective on three well-known public stereo matching benchmarks called Kitty, ETH3D, and Middlebury. Compared with IGV stereo and selective IGV, our GREAT IGV and GREAT selective obtain a large margin optimization through these three public benchmarks. As for the ill-posed issues tackling capability, we provide some visualization results of our GREAT IGV and GREAT selective on SynFlow, Kitty, ETH3D, and the Middlebury dataset. The ill-posed regions are emphasized by the white box. Through the visualization result, we can see that our GREAT IGV and the GREAT selective get the best performance inside the ill-posed regions, compared with other iterative-based stereo matching methods. At the end of this video, we also provide you some point cloud reconstruction demos generated by our GREAT framework. Please have a look.